This is a machine that's making metal bars to contribute to houses. But how does it work? Long pieces of metal are called rebar or reinforcing bars. They're made from steel, which is an alloy primarily composed of iron with small amounts of carbon and other elements. The mixture is melted down and then formed into these long continuous lengths, which are then cut to size. And this is why the process of making steel rebar is so fascinating. There are dozens of machines like this one in operation all around the world, but the way they make these long metal bars is quite secretive. Most companies won't let anyone film their factories for fear of someone stealing their manufacturing process. But fortunately, we were able to find footage of a similar machine that uses a casting wheel instead of a rolling wheel. And by understanding how this machine works, we can get a good idea of how this one works. The first step in making steel rebar is to melt down the raw materials. This requires temperatures of over 1500 degrees Celsius, which is hot enough to melt most metals. Once the mixture has fully liquefied, it's held in a ladle, while the slag, which is a byproduct of the smelting process, is removed. This mixture is very pure, and the reason why it's not completely pure is because some impurities actually make the steel stronger. For example, manganese improves its strength and elasticity, while silicon and sulfur improve its hardenability and machinability. Of course, there is a limit to this, and too much of an impurity will have the opposite effect and weaken the steel. Once the slag has been removed, the molten material is transported from the smelter to the rolling machine. This machine consists of a large wheel called a roll, which is heated to around 500 degrees Celsius. The roll is coated with a lubricant to prevent the steel from sticking to it. A hydraulic press applies pressure to push the steel onto the roll where it's guided by rollers to ensure it's in the center. As the steel makes contact with the roll, a water-cooled spray bar is used to cool it down so it doesn't stick. A series of rolls pull the steel in the opposite direction to feed it into the machine. The purpose of these rolls is to flatten the steel to form a slab. Unfortunately, in this process, some of the steel breaks apart due to the cooling and hardening process, which means the rolls need to be thick enough to absorb the energy of the impact. Fortunately, the roll is supported by a hydraulic buffer system that resists these impacts and keeps the machine stable. Once the steel is flattened, it's still too wide and needs to be rolled again. This time the goal isn't to flatten it, but to elongate it. This is done by rotating the roll, which changes the angle of the steel. As the steel is pushed against the roll, gravity pulls it downwards, and the machine uses a pulling force to counteract this and pull the steel back upwards. The result is that the steel is elongated while maintaining its thickness. If the steel was softer, it would simply stretch. But because it's been cooled and hardened, it elongates while also thickening, which makes it stronger. The steel is rolled back and forth multiple times until it reaches the desired length. Finally, the excess material on both sides is cut off and the bar is removed. From here, the bars are placed on racks and taken away to be cut to length. This is done using an abrasive saw which cuts at around 100 bars per minute. Once the bars are cut to size, they're ready to be used in construction. Now, you might be wondering, how is this any different from a normal casting machine? Well, to answer that question, we found footage of both machines running side by side, which gives us a great opportunity to compare them. As you can see, the first difference is that this machine has a vertical roll, whereas the horizontal one has a horizontal roll. This is probably done to make it easier to load the steel onto the roll. In the case of the vertical machine, the steel is loaded in the middle and is pulled in from either end. With the horizontal machine, the steel is loaded from one end and pulled through the entire length of the machine. Secondly, the horizontal machine has a set of rollers at the end of the machine to straighten the steel, whereas the vertical machine seems to use a combination of rolls and water jets to both straighten and cool the steel. Finally, the horizontal machine has two sets of rolls, whereas the vertical machine only has one. Let us take a closer look at the horizontal machine and see how it compares to the casting machine. The first thing to note is how the steel is fed into the machine. The steel is loaded onto a carriage which slides onto rails that run the length of the machine. Hydraulic pistons push the carriage forward to feed the steel into the machine. At the front of the machine, a set of rollers aligns the steel and pushes it onto the roll. Just like before, water jets are used to cool the steel and prevent it from sticking to the roll. However, unlike the casting machine, there aren't any rolls to pull the steel back. Instead, tension is applied to the steel using hydraulic cylinders, which also helps to straighten the steel. Because of this, the steel is constantly being pulled forward, and the roll applies torque to the steel, causing it to rotate and elongate. As it rotates, the steel comes into contact with more water jets, which cools and hardens the steel. Due to the tension applied to the steel, this causes the steel to shrink in diameter as it's elongated.
Oh.
The steel exits the machine through a set of rollers that help to straighten it. If you want to support the channel and access our community, consider becoming a member. We also have a second channel that publishes additional content that might interest you. Thanks for watching.